In this question, a proton, a deuteron, and an alpha particle are accelerated through same potential difference and then subjected to uniform magnetic field B perpendicular to the direction of their motion. So magnetic field is perpendicular to the direction of their motion. Then what is saying? Compare their kinetic energy, and if radius of circular path described by proton is 5 centimeter, determine the radii of path described by deuteron and alpha particle. So you have to calculate the radii of both deuteron and alpha particles simultaneously over here. So, first thing is that we'll first try to compare their kinetic energy. Okay, so how will compare the kinetic energy? First of all, you have to find out the kinetic energy, and after that, we'll take their ratio. By taking their ratio, you can compare. So, how will you get that one? So, before that one, try to understand the question first, what it is trying to say. So, this is the figure. In this particular figure, we just look. So here, proton return these three particles. These are positively charged particles. They accelerated through same potential difference and then subjected to uniform magnetic field. So first of all, some potential difference region is created where the charged particles are accelerated, and after that they are moved in a uniform magnetic field. So this is uniform magnetic field, which is let it be inward, directed inward, and this is the region of electric field where potential difference created is V. So as this is a positively charged plate, so negative charged plate having some potential difference, so field is towards right, so all these charged particles will start moving, will start accelerating towards right. So after reaching over here at this particular point, suppose here in this particular piece, let me draw the figures first. This is not the actual is, so initially they will be having some initially as they have just started their motion, so they will be having some little bit less speed, but as soon as they will here at this particular instant, they will be having some more speed as they are accelerating in an electric field, and when they reach at this point, they will be having some speed which will be the maximum one. That means they will be having maximum kinetic energy. So the velocity over here, when they over let velocity for three different particles be with which they will enter this uniform magnetic field. So as soon as they enter this uniform magnetic field, so so what will happen? So it will experience the force due to magnetic field. Force due to magnetic field is given by Q into V cross B. Clear? So this will be the force, and here due to the presence of electric field, it will experience the force as F equal to Q into E, due to which it is getting accelerated. Okay, so first what we'll try to do, when this charged particle is getting accelerated in a potential difference of V, then what is the energy gained here? So energy gained by the charged particle, it will be nothing but E equal to how much? It will be equal to Q into V. Clear? Energy, we know that the potential energy formula is U equal to Q into V, or V equal to U upon Q. So this energy is stored in the charged particle in the form of kinetic energy. That kinetic energy equal to E into V. Clear? Or you can say Q into V. So for positive charge particle, which is for all these positive charge particles, for alpha particle, which is having some for proton will be having kinetic energy as E into V. That means proton is having charge E, that is 1.6 into 10 to the minus 19 coulomb. This is for proton, and similarly for deuteron. So for deuteron, let it be again, deuteron is having same charge as that of proton, so it will be again accelerated through potential difference of V, same potential difference. So kinetic energy gained will be EV, and for alpha particle, alpha, so it will be twice its charge is twice that of proton, so it will be 2e, charge is 2e, and accelerated through a potential difference V. That means kinetic energy gained by it will be 2ev. Clear? So if we take the ratio of these three, so then the ratio, what will be the ratio? The ratio will be Kp is to KD is to K alpha will be equal to EV is to EV is to 2EV. So this EV will get cancelled out. So finally how much will be getting? 1 is to 1 is to 2. So ratio of these particles will be getting 1 is to 1 is to 2. Okay. So this will be the case. First comparison case ratio will be this one. And if radius of circular part described by proton is 5 centimeters, so now it is saying radius why radius part is coming, because this charged particle starts moving in a uniform magnetic field v with some speed, and this speed, or you can say velocity, is perpendicular to magnetic field b. So that's why all these particles will experience some force. So force, what is the direction of force? Force will be perpendicular to the both velocity as well as magnetic field. So if you move your fingers from B to B, so then the force is directed upward. Here force is directed upward. So in all these particles, force will be directed upward. Here, so due to this force, what will happen? So this charged particle will undergo some sort of circular motion. Here also it will undergo some sort of circular motion. Here also this will undergo some sort of circular motion. So what is the radius of all these circular motion? That means circular paths they will undergo. So radius we can find it out. So formula, by using the formula R equal to mv upon q into b. Clear? So this is the formula to find out. So now we'll try to check which particle will be having greater radius. So this radius depends upon, first the thing is that can say um, that mass wise, if we mass wise this particular case, if we check how this radius depends upon mass. So mass wise, we can say mass, if mass of proton let it be m, then mass of deuteron will be twice of that one. Mass of alpha particle will be 4 times of the mass of that proton. Clear? And charge, we know that charge, we can say the charge of proton will be equal to E, then charge of deuteron will be equal to E, and charge of alpha particle will be equal to twice of E. Clear? Twice that of proton. Clear? So mass has gone, charge has gone, next velocity. So velocity and magnetic field. So we know that magnetic field is uniform, so that one remains constant over here. Okay. So now what we can say over here is that this or else another thing we can see, we can write, we don't know what is the velocity, and again we have to find it out. So we'll try to write this radius, this momentum of individual particle. This indicates what? This indicates the momentum. Okay. So this momentum of individual particle will be trying to write in terms of kinetic energy. We know that a equal to half m v square, or it will be equal to p square by 2m. Clear? So p equal to under root 2m k. Okay. So using this formula we can write, so it will be equal to 2 mass of the given particles and kinetic energy of the given particles, and of that one divided by q into b. Okay. So now we'll take ratio of this of the radius of all these particles. Ratio radius of proton is to radius of deuteron to radius of alpha particle. So it will be nothing but 2 into mass of proton, kinetic energy of proton, the root of that one, all divided by charge of proton into magnetic field is 2 into mass of deuteron, kinetic energy of deuteron, so root of that one, all divided by charge of deuteron into magnetic field, and alpha, radius of alpha particle will be equal to 2 into mass of alpha particle, kinetic energy of alpha particle, all divided by charge of alpha particle into magnetic. So first thing is that this magnetic field, magnetic field will get cancelled out. Root this 2 and 2, and a root also. Okay, will not take a root. We'll keep it as it is. Now we'll be putting the values. So we know that root of here. Okay, root will get cancelled. Root 2 will get cancelled out. So finally remaining part is that mp root of mp divided by qp is to root of md. Okay, here kp root of kp is also there, and okay, okay, here root of kp root of kd divided by p is to root of m alpha a alpha divided by. Okay, so we'll put in the values over here. So if we try to write, we try to check the first case, kp kd k alpha 1 is to 1 is to, clear. So that means if we try to write, if kp kinetic energy of proton is k, then that will be equal to kinetic energy of deuteron, and kinetic energy of alpha will be equal to twice of k. That, so in that sense, if we try to write this one, so this will be equal to mass of proton, that will be m into k, the root of that one, whole divided by charge of proton is e, is to 2m is k divided by charge of deuteron is e, is to mass of alpha is 4 times m. Get kinetic energy of this alpha particle will be how much we got, twice 2k, and root of that one divided by charge of alpha is twice of e. So e e e will get cancelled out, and here mk we can take mk, this m and k, this can get cancelled out. So here will be what will be getting, 1 is to root 2 is 2. Here how much will be 2 under root 4, that is 2, 2 by 2, that is 1. Okay, so the radius ratio of the radius here, ratio of radius of proton is to radius of deuteron is to radius of alpha particle. How much we are getting, we are getting this one. Okay, so that means radius of deuteron is root 2 times the radius of proton, and radius of alpha particle will be same as the radius of proton. Clear? So radius of alpha will be same as the radius of proton, and radius of deuteron will be root 2 times the radius of proton. Clear? So that means here, if radius of proton is 5 centimeter, in the question it is given that radius of proton is how much, it is mentioned over here. Let me check. 5 centimeter, I think. Yes, radii of proton is 5 centimeter. That means radii of alpha particle will be same as that one, and radii of deuteron is root 2 times. That means it will be root 2 times 5. Yes, or it will be equal to 5 root 2 centimeter radius of deuteron. Okay, so this is the case. Final answer.